Hey guys, we're going to take a look at some different models of the atom. In section 17.1, we're studying atoms, and we'll look at how people thought about these starting way back in 1803 and then continuing up until about pretty near 100 years ago, right? So let's start with John Dalton. I'm going to try to embiggen this. Maybe I can't do that. Okay, well, you'll have this slide available to you. John Dalton was a Quaker school teacher. He taught math at a one-room schoolhouse in England. He was a meteorologist. He kept 40 years of pretty detailed meteorological records. He was an excellent mathematician. He was colorblind, and so for many years, colorblindness was called Daltonism. I think it still is in French. But he did some of the first research into color blindness, but he also gave us the first modern model of the atom. John Dalton thought about atoms as pool balls. In fact, and not even necessarily pool balls, but as solid objects. They could be cubes or blocks, like the blocks little kids play with, but mostly pool balls. And he thought about them in slightly different ways. Sometimes he imagined they would have hooks on them so that they would stick together. Solids, metals, rocks, things that were hard and durable and difficult to break would be made of atoms with hooks on them, for example, while liquids or gases might be made of atoms that were just spheres that could move past each other and flow past each other. This is his idea. Dalton came up with the idea that anything you can drop on your foot has to be made out of atoms. That idea had come up about 2,000 years earlier, but it's sort of been forgotten about, I think, and Dalton resurrected it. He said that atoms of different elements are always different from each other. In other words, a competent chemist will never confuse hydrogen and helium. Those two atoms have to be different from each other. He also said that atoms of the same element, say hydrogen, all have to be identical to each other. Well, there you go. You can make of that what you will, but Dalton's big contribution was to give us the very first model of the atom. Then we go forward in time about 100 years to J.J. Thomson. J.J. Thomson invented what was effectively the very first TV tube. And what he did was a little bit involved. We're not going to go into the details of it, but he figured out a way to shoot electrons at a screen. And when the electrons would hit the screen would glow, right? So that's kind of how an old-fashioned boxy TV works. If you take one apart, you'll find the electron gun sitting in it, right? J.J. Thomson was also from England. J.J. Thomson called these things cathode rays. Today, we don't use the term cathode ray, we use the term electron. But he discovered electrons, right? Although he didn't use the same word, he called them cathode rays. J.J. Thomson's model up here is called the plum pudding model, but most of us aren't familiar with plum pudding, so we'll call it the chocolate chip cookie dough model. Here's what he discovered. He discovered that atoms have positive and negative pieces, and he discovered that the negative pieces can come off. Atoms have positive and negative pieces, and the negative pieces can come off. And so if you think of this as a chocolate chip cookie dough, the positive charge of the atom is the dough. The negative charge are the chocolate chips that can be removed. All right, now we go forward in time about a decade to Ernest Rutherford. Ernest Rutherford was from New Zealand, and he set up something called the gold foil experiment. He basically shot tiny little atomic bullets at a very, very thin sheet of gold and looked at what happened. And what he found really surprised him. Ernest Rutherford came up with 3 conclusions. The first conclusion is that atoms are 99.9% empty space. The second conclusion is that all the mass of the atom is concentrated in a tiny, tiny nucleus. And the third conclusion is that all the positive charge of the atom is concentrated in that tiny nucleus. And since Ernest Rutherford was talking about a nucleus, his model is called the nuclear model. All right, now we go forward in time just a few more years to Niels Bohr. Niels Bohr was from Denmark, and he came up with something called the planetary model. He envisioned the tiny, positive, massive nucleus at the center of the atom. And then he thought about the electrons as following circular orbits around the nucleus, just the same way that planets orbit the sun. And that's the reason it's called the planetary model. And so in the planetary model of Niels Bohr, you've got the nucleus at the center, and then you've got electrons going around the nucleus on these rings. And then finally, about a decade, maybe 15 years after that, we come to the quantum model, but we're going to call it the wave model, right? The modern model is the wave model. Erwin Schrödinger's name is put down here, but there were quite a few different people that contributed to this. I'm not going to quiz you on the name Erwin Schrödinger. The wave model is different from the planetary model in one important way. Here's how they're the same. They both have a tiny, massive, positive nucleus at the center of the atom. But the planetary model has electrons going around on rings. The quantum model, the wave model, has electrons buzzing around the nucleus like flies around a light on a warm summer evening when it's dark outside. Think about that. Flies are going to tend to congregate, or insects are going to tend to congregate closer to the light. And as you move away from that light, you'll find fewer and fewer bugs, right? But there will be a few bugs that from time to time stray far away from the light. And so that's the way we think of electrons today, as bugs buzzing around in a random way. You can't really predict where they're going to go. They're buzzing randomly around the nucleus, so to speak. So that's the wave model of the atom.